Hey, wonderful students. Hope you're having a wonderful day so far. Yesterday we were talking about probability in general, and today we're going to talk about one kind of probability called experimental probability. And it's a way of estimating the probability of an event based on what's already happened. So I have a spinner here with 4 names, and I'm going to use a pencil and a paper clip as my spinner. And let's see. I got 1 for Grace. Let's see what comes next. I got a Lily, so 1 for Lily. Oh, I got another Grace. 2 for Grace. 1 for Ian, barely. That was almost another 1 for Grace. All right, we need a Logan. Another Grace? Wow. Another Grace, holy moly. All right, let's stop there. So I spun my spinner 6 times. 1, 2, 3, 4, 5, and 6. So experimental probability says to take the number of times that something happened and take it out of the total number of times and then report that as a fraction. So if for Grace, 4 out of the 6 times, I would say the probability of getting Grace was 4 out of 6. 4 out of 6. Let's go back. Ian, I got 1 spin for Ian and 1 spin for Lily. So the probability of getting Ian was 1 out of 6. The probability of getting Lily was 1 out of 6. And the probability of spinning a Logan, sadly, was 0 out of 6. And this means that it is impossible. You remember that. So let's look at these numbers. Oh, I know something else I wanted to say. Down here, if the numerator is 0, it means the probability is 0. So up here with Grace, a 4 out of 6 chance. What that means is, since this is what we saw in the past, this is what we expect to see in the future. Now, maybe there's a little something on the paper that made the spinner keep going there, but there is a better chance of landing on Grace than there is these other names. So we say the experimental probability was 4 out of 6. The experimental probability of Ian was 1 out of 6. And the experimental probability of Lily was 1 out of 6. And the experimental probability of Logan was 0. So that's all experimental probability is. It is the number of times something happened over the total number of, we call that trials. So the number of times I held my experiment. So the total number of times something happened for Grace was 4. The total number of trials, that meant 6 spins. So the number of times something happened over the number of trials. Now, one thing I would say about this is if you can simplify a fraction to lower terms, we will always do that with probability. So since this fraction, both numerator and denominator are divisible by 2, we say that the experimental probability is 4 divided by 2 is 2. 6 divided by 2 is 3. So 4/6 simplifies to 2/3. Okay, so let's look at something else. And now you're ready to do some writing with me. If you have a printer at home and you want to print this and fill in the blanks rather than writing it all out, I am totally fine with that. You don't have to copy my pictures. What you do need to do is copy this table right here. So an experiment was done. 5 times I spun a red. 4 times I spun a pink. 7 times I got a blue. So the experimental probability of getting a red, remember, I'm looking for the number of times that something happened. So how many times did we get a red? 5 over the total number of trials. What is that? That means, remember, the total number of times that I was spinning that spinner. So I take my chart over here, 5 plus 4 is 9, plus 7, this is a total of 16. So the probability, the experimental probability of getting a red was 5 out of 16. Let's look at this one now. So the experimental probability of getting a pink. So how many times did I get a pink? I got a pink 4 times, that's my numerator, out of a total of 16 spins. 4 out of 16. That simplifies because top and bottom are both divisible by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4. So the experimental probability of getting a pink was 1 out of 4. What's the experimental probability of getting a blue? Well, let's see. The number of times I got a blue was 7. The total number of spins, remember we added these 3 numbers up, was 16. All right, let's come down here. So sometimes you get information in a table. This was like a vertical table here, and this is more of a horizontal table. You don't have to draw the dice, kids. That's fine. But you'll need to make a table that shows that a roll of 1 happened 4 times. A roll of 2 happened 5 times. A roll of 3 happened 5 times. When I rolled 4s, that happened 6 times. Rolling a 5, well, that only happened twice. And rolling a 6 happened 3 times. So maybe this die is a little weighted in some way, that it's not going to turn out even Steven getting 1 through 6 on those. So remember, the experimental probability, let me put this back out here. The experimental probability is the number of times something happened, that's our numerator, over the number of trials. So let's go back to our dice chart. Before we can really go any further, we need to know what's the total number of trials. Where do we get that information? Are we adding up these numbers? Or are we adding up these numbers? So remember, this 4 represents the number of times I got a 1. These numbers tell how many times, or we got the frequency. We call that the frequency. So let's see. I see that I've got 5 and 5 are 10. Here's another 10, so that's 20. These 4 numbers added up are 20. 21, 22, 23, 24, 25. So I had 25 times I rolled that die. So what was the experimental probability of getting a 1? Well, the number of times I got a 1 was 4. The total number of times I rolled was 25. So 4 out of 25. The experimental probability of getting a 4, that's not a very good looking picture, but I had 6 4s. So we say the experimental probability was 6 out of 25. How about the experimental probability of getting a 2? I'm going to move this over here. It's getting a little crowded. Well, I got 5 2s out of 25 rolls. And since both numerator and denominator can be divided by 5, that simplified probability is 1 out of 5. Okay, so now we're going to look at some ones that are a little more complicated. So, what is the experimental probability of getting a 5 or a 6? What's that mean? That means if I were going to give you $1 every time you rolled a 5 or a 6, how many times did you win that $1? Well, you won $1 here for the 2 5s, and you won some more money over here for the 6. So the ways that you can get that 5 or the 6, there were 1, 2, 3, 4, 5. So it is 5 out of total number of rolls, 25. And just like we simplified 5 over 25 to 1 over 5 here, we can do that here. So what's the probability of not getting a 3? What's that mean? That means what's the probability that I got anything except a 3? So I want to know the number of rolls in which I did not roll a 3. So I'm going to cover up the values for the 3 right there with my paper clip. So I need to count up all these numbers here. And when I add up 4 plus 5 plus 6 plus 2 plus 3, I get 20. So the probability of not getting a 3 is 20 over 25. Can that fraction be simplified? It can. Top and bottom can both be divided by 5. 20 divided by 5 is 4. And 25 divided by 5 is 5. So the probability of not getting a 3 is 4 out of 5, the experimental probability. What's the probability of not getting a 1? Well, let's cover up the ones that we got. So the probability of not 1 means of all the other things that we got, what was the total of those not getting a 1? And when I add up all those numbers, I get 21 out of 25. And that cannot be simplified. So, experimental probability means I take the number of times that something happened and I put it over the number of trials. I'm going to write that again just so that you see it out in front of you. It is the number of times something happened over the number of trials. Okay, so let me put some independent work out for you. And again, this page is kind of a bit of copying. So if you have a printer at home and you want to print it and just fill it in, that's totally fine. But what I need to see on your paper is this chart. So it looks like some students were surveyed about the types of pets they have. And let's see, there were all these types of pets and the frequency. What does that mean, the frequency? That means how many times did this happen? So for the type of pet, of dog, it happened 10 times that a student said they had a dog. That is the frequency, 10. Same thing with the cat. If it has a frequency of 2, 2 students say they have cats. And then fish and rabbit. So what you need to do is copy the table, fill in the frequency. You know you need to take care of that. The total frequency, because that's the total number of trials. How many kids did we ask? That's what the total will be. And you will get that by adding up all of these numbers. So using your table, you are going to find probability of fish, probability of getting rabbit, the probability there was a dog or a cat selected, and so on. So again, I'm sorry about the amount of copying if you don't have a printer, but I do really need to see all of this on your paper. I know you're going to do your very best work on this. I always appreciate your solid efforts. And I just could not be wishing any more that you would have a wonderful day. Bye, kids.